Hello there, Eric here. And in one of the first parts in this digital literacy series, we're going to try and wrap our heads around the enormous size and complexity of the internet and kind of get a basic understanding about how it all works. So first, let us take a look at this image. This is supposed to represent the internet. Now, a lot of artists and statisticians and mathematicians have tried to represent the internet visually in some way or another. And this is one of the projects that came about a couple years ago. And each one of these intersections, each one of these lines represents a connection between devices, a not a physical connection perhaps, but a connection where messages are being sent back and forth with a virtual connection between PCs or any kind of device that's connected to the internet. As you can see, it's huge and it's hard to imagine now all the different things now that are connected to the internet. So we're going to kind of refer back to this image, this idea, this representation of the internet as we go through this short video. Well, you can, if you wanted to call the internet something, you can call it a network of networks. You might have a few PCs that are connected to each other in a local network, but those local networks are then connected to bigger networks, and those networks connected to other networks, and they're all connected to each other. And what's amazing even more is that not just one kind of person or system or government or type of user is connected to the internet. We have governments, we have nonprofit organizations, we have business, and a wide range of things. Almost everything is connected and sharing the same system. And that's really kind of an amazing thing in itself. So it's built on this TCP/IP idea. We're going to get into it in a second. And there's a lot of different layers built on this idea on top of it. And we have things like the World Wide Web and telephony and file sharing and all the things that we've come to know in our smartphones as well. So to kind of get a sense about the history and how this got started, there was a time in history when the Russians were the first to send up a satellite to orbit the Earth. And it was called Sputnik, and it made a lot of Americans uncomfortable or embarrassed or afraid, depending on who you ask, of course. So the government decided to step up its efforts in research and development into a variety of technologies, but one we're going to be talking about is the technology of computing, and more specifically, how we can connect computers together. Because in the business of launching things into space, we need a lot of computing power, and there's a lot of space to cover in space. So we need to have people from all over the world and all over large vastness of space on the ground connected in order to console our resources and have the computing power needed to calculate things and launch them into space. So at the beginning, we had this great collaboration already, this what we kind of see in the internet today, this collaboration between business, education, and government. And that's largely due to some early decisions made by who got put in charge of this kind of research project to try and link computers together so we can share resources and data. This is Dr. Linkletter. And what he did, one of the key decisions that he made early on, is he wanted not just to have government contractors, defense contractors working for the government involved in this, but he also wanted to involve private industry, and more importantly, he invited research institutions around the United States to join in on this project and what would become the ARPANET. And if you're calling anything version 1.0, you can call the ARPANET kind of the beta internet, the first version of the internet. And it had machine from IBM and SDS, and it connected networks from universities on the West Coast and the University of California, Utah, and it involved the Department of Defense. They're all kind of collaborating together. And this is one of the reasons, these first early decisions, I think, is why we have such an amazing range of governments and private industry and normal citizens sharing this vast network today. So one of the most important things that happened in the early stage and in the ARPANET is we went from circuit switching to packet switching. And what we see here is an older version of a telephone service when you wanted to connect one person to talk to another person. And you needed to have a circuit, a physical circuit of wires connecting one point to another, to one person to another, so they can use that wire to talk back and forth and share data. Well, that's a lot of times not so convenient. Maybe you want to switch between talking from one person to another very quickly, or maybe a lot of people need to talk to the same person. So we all need a way to kind of use the same pipe, the same wire at the same time. And that's what packets did for us, packet switching. So instead of switching the circuit between connecting one point to another and making a whole circuit, we now switch packets of information, allowing different people to use the same pipes, use the same wires to send information back and forth. We just share time on it by sparsing up our data, sparsing up our information into small packets and taking turns sending those through the pipes, sending those through the wires. So at first, when we had the ARPANET, we only had these 4 points, these 4 university campuses that were connected via the ARPANET, right? And it grew in just 1 year to some universities on the East Coast. And then it grew again in 72, and then towards the late 70s, mid to late 70s, we started using satellite information. Over here we can see we have London connected, the Pentagon was connected. We have businesses and universities and the government all on the same network, sharing information, sharing computer resources. And then that's 1977. So we went from just 4 points on ARPANET to dozens of them in 1977. And of course, we come back to our picture again, where we have millions and millions of connections of PCs, of cell phones, of even now these days, Fitbits and refrigerators and microwaves and driverless cars and anything you can think of that's some sort of connected device, connected instrument or thing to the internet. So we went from those 4 points to countless of millions of points. And they're all connected in some way or another, sharing the same network. That's quite amazing when you think about it. And it's made possible by TCP/IP technology, right? TCP/IP stands for Transmission Control Protocol. This is what makes that packet switching possible that I talked about just a minute ago. It's the system that breaks our information down into small packets so we can all use the same wires, the same pipes from which to send information to. And Internet Protocol is basically a set of rules and protocol that allows all of the computers to share a basic set of ways to connect and talk to each other. So everybody has a baseline set of communications. For example, we all know that IP addresses contain a set of numbers. So every PC or connected device on the internet has an internet address, and this internet protocol, part of that protocol is this address system. So And TCP/IP is kind of broken into layers, right? So we can add information back to the front and back end of these packets of information before we send them out. And one of the most important things that we add to that, all these packets of information, is a to and from address, so that when they go out on the internet and one PC wants to pass it along to another PC on the network, it knows where it's going. And then all these connected devices can help route data for each other on the internet. And then we have these layers on the internet as well. So our TCP/IP layers help us break down information apart, and so we can use the same pipes, the same lines to transmit information. But on top of that, we want to know what kind of information we're sending. So we have things like the HTTP layer that we use for the World Wide Web. We have an FTP layer where we use to send files, and other layers like that allow the front and back end computer to put on top of our TCP/IP protocols, to which they can have a bigger set of rules to know how to transmit data for a specific purpose. Right. So let's just take a look maybe at how that might look. Let me maybe bring up a command screen. This is basically just a DOS screen I'm going to bring up. Okay. Now what I can do now is, this is a Windows, you can do this on almost any Windows PC. You can try it yourself at home. I'm going to try and ping something. Now I can ping an internet address, which is usually a number which is 4 numbers separated by periods, 1 to 255, 1 to 2 in 4 numbers. So every internet address is 1 to 255 that's connected to the internet or your local area network. But we all know now that we have internet domains or URLs, and those are actually PCs on the network that translate these .coms or .orgs into internet addresses. So I'm just going to ping something, which means send it a byte of data, 1 packet of data, and see how long it takes to return. So we tried to ping it 4 times, and it took 184 milliseconds to do a round trip, right? It sent it 4 times, no packets were lost. And just to give you an idea, I'm sending this from my office in Japan, and my server, my website server, is hosted somewhere in America, in the Southwest. So it traveled all the way from Japan to ping my website, or the server which my website is hosted, and came all the way back. So this is the IP address from which it was translated to, and then it came back. We can actually kind of see all the steps it takes between here and there by doing a trace route. So now what's going to happen is we're going to send a couple of packets of information, but we're going to see how it gets routed and where it gets routed on every step of the way. So I have my local area network, which is connected to a router in my office. That probably goes to somewhere on campus where it's getting resent out to another network somewhere else, perhaps on campus. And this is timed out. This is actually kind of unusual. See, one of the things on the TCP/IP protocol is that when we split data packets up, when we send them out, sometimes they get lost. And your data packets might not even take the same route to get to their destination, and they get put together when they reach their destination. And so if something doesn't reach its point, when the data gets put back together at its destination and something's missing, we can then ask or send a request to the sending address to resend that bit of information so we can have it all back and put back together. This is disappointing that it's not working right now, but you can see that it starts with one IP address and goes down. And what this is probably timing out somewhere between a university and some local servers before then it would get passed on to probably 14 or 15 different PCs on its way to the United States. And it might go through a satellite connection or in low Earth orbit, or it might go through some pipes under the ocean floor. And we can see it timed out, the trace timed out for all these steps. But when it gets to its final destination, we can see what server it actually ended up in. So this is not a very good example of the trace route, but you can try that at home, and you can see all the different IP addresses from which information gets passed to go from one place to another. So you try that at home, right? You go to start, if you're on a Windows PC, you start, run, type in command, and try and ping a website or trace route a website. You get an idea of this TCP/IP protocol and how it starts to send bits of data from one end to the other. We can visualize the internet in a couple of other different ways, and one of the ways is using the size and amount of traffic data that's being represented on the World Wide Web, the HTTP layer on the internet. We see this in the size of the bubbles here. Or we can think about the physical connections. These are actually wires that are run through the ocean that connect different places on Earth that our internet telecommunication signals are traveling through. And of course, we have thousands of satellites in orbit, many of which are telecommunication satellites from which we are bouncing information for use of internet data as well. So it's amazing to think of all this different connections all working together to make sure you and your bits of data, your message, gets sent from one part of the network to another. Right, that's been Eric talking about the basics of the internet. We're going to go in another video and talk about these other specific ways, tools to visualize the internet in another video. But for now, we'll see you again next time.